Our presentation today is on lithium battery safety and risk. This is a subject that I've sat back. I have a list of different topics that I'm like, I really need to build something on that subject. And as I get some time, I I put these together. And this is a new presentation for us today. And so I hope it's something that's beneficial to you. If you have any questions or comments about it, we'd absolutely love to hear those. And looking at the signups, we had significant number of people from fire service, and I know you have some specific interest in this, and I would love to hear from you what your experience has been dealing with EVs and dealing with batteries in a lot of different environments because things are changing quickly. So, starting out, batteries are everywhere. As I started researching and putting this presentation together, I was sitting in my home office typing away, and I looked around at my desk and the areas around there in my home office, and I had a flashlight, and I had a battery pack that I used to take backpacking with me, and I had headlights, and I and with these little lithium ion batteries, and I had over a dozen different devices that had a lithium ion battery in it within arm's reach in my office at my house. And that was kind of striking just how impactful these batteries are in everything that we do. And you could probably do the same around your work area, around your home office, around your home or garage, and see just how much of an impact these batteries are having. I'll ask a question though. Do you have large batteries in your operation? This is something that's changing rapidly. We're bringing in large battery systems, whether for large electric vehicles like buses and garbage trucks, or things like power storage systems where we may have a solar or a wind power array, and we're trying to store that energy in systems. Sometimes we have outside agencies that come in and they put in a data center on our property because we have a good piece of property for that. And they have large battery backup systems for those systems. And so we're seeing more and more of these large batteries. Well, let's get back to just kind of the basics of batteries. We have used batteries for really centuries. Lead acid batteries were really the first type of battery that we used, and they're still in use today. Your car battery is a cell that has lead as well as sulfuric acid in there as an electrolyte. Lead acid are great batteries, but they're heavy. Their lives are not really long, and lead's toxic. Alkaline batteries are like our AA, AAA batteries, 9-volt batteries, are great batteries. They're not very energy dense. They don't have a lot of power in those cells, and most of them aren't rechargeable. We throw those away when we're done. Nickel cadmium, those got a little better. They had a lot more energy density or more power contained in that type of cell. But the problem with those is they develop memories. And so if we don't recharge those right, or we don't recharge them for a long time, they may just forget how to be charged and discharged, and they just don't work that well. So along came lithium batteries in the previous few decades. And they came along and fixed all of our problems. And the answer to that is not. But they're really pretty amazing batteries. They will do things that other batteries just won't. And so we're throwing this type of battery, the lithium ion battery, in everything, in personal electronics, in vehicles. 20% of the vehicles sold, and these are passenger cars, in 2021 were electric vehicles. There are about 6.8 million electric vehicles on the road right now, with estimates that by the early 2030s, we'll have 130 million electric vehicles on the roads. And like I said, we have these energy storage systems. We have data centers that are using massive battery systems using these lithium ion batteries. So things have changed significantly. We use batteries now for tools that we would never consider using it for in the past. Well, let's talk just kind of how batteries work, just very basic. It's not a chemistry class. You have an anode and a cathode. These are different metals, and they use an electrolyte that will help them to store electrons on one side or the other. And as they pass, that discharges the battery and changes the electrical potential of those metals in the cell. There is a separator between those and some sort of electrolyte. So you think about electrolytes in a lead acid battery, your car battery, that's sulfuric acid. But in lithium batteries, it's something different. They will use something like an organic carbonate that will be in there. And they have their own hazards. And we'll talk about those in a minute. And those electrolytes, when we talk about that, we think of electrolytes as maybe being liquids. In most cases, they're in some sort of gel or matrix in there. So they're not necessarily liquid, but they are something that can transfer those electrons relatively easily. All right, different types of lithium batteries. Lithium metal batteries were the first ones that came about. They're the ones you see on the right here, those button cells that we put in a watch or hearing aids or other small devices. And these are a power pack battery that can provide really a lot of power in a very small package. Risk with lithium metal batteries is that they're made with lithium metal, and if they get broken open and there happens to be a fire and we put water on it, or if we just put water on it, they're water reactive, and that will accentuate the fire, make it burn extremely hot, and so there's some danger associated with lithium metal. Well, fast forward a little bit, and we have developed lithium ion batteries, and these have dozens of different chemistries that are being used, and more are being developed every day, because one chemistry over another may provide a little more energy density, or I can pack more energy into that battery. Or it works better to recharge on time, et cetera, et cetera. All of the different characteristics that we talk about in a battery, it's that chemistry that goes in there, particularly the electrolyte and how the anode and cathode interact, that really make the difference on how the battery functions. There are unique hazards for each type of battery and each type of chemistry, because if a battery fails, or it's overheated, or it catches on fire, it's involved in a fire, those chemistries are going to react uniquely to the type of chemistry that they are. And that makes it a little bit of a challenge because of what we have to deal with. Particularly, like I said, we have a lot on this presentation in the fire service. You got to deal with everything. You got to be prepared for everything. And here's an important consideration: is the size of these batteries are really exponentially expanding in size. They're getting bigger and bigger to satisfy the demands that we have. Just for example, with the proliferation of solar arrays around the country, and particularly here in the Southwest, those arrays work great. Solar's great when the sun's shining, but when the sun isn't shining, we don't have any power. So they had to search for ways that we could have power when the sun's down. And that's a challenge. And so they built these massive energy storage systems that involve really, really large lithium ion batteries. Matter of fact, there was one that fell off of a truck in Richfield, Utah, here in the last couple of months. A 77,000 pound lithium ion battery um, fell off of a trailer. It looks like it kind of collapsed the trailer as they were trying to make a turn into a truck stop. Imagine that, trying to get a crane out there to safely lift that on. Fortunately, the cell didn't fail; it wasn't damaged, and so they were able to safely get it back on the truck with some effort. But imagine these types of batteries moving through our communities, or maybe being fixed in our communities as an energy storage device, and along with the hazards that we'll talk about in just a minute. Lithium battery traits, they are very energy dense for their mass and their volume. They carry a lot of energy. I put this picture on here with all the Milwaukee tools because I have some sons that really think Milwaukee tools are great, and I have one son who worked for a company that had an employee discount where they could buy, and I think he bought one of each, one of everything they had. There's a lot of red in his toolbox, and these batteries have really blown my mind when I see those tools and what they're able to accomplish with the energy that is in those tools. And so, with that, the type of tools that we're using and the number of batteries that we use have really proliferated. And so there are toolboxes, a lot of them red, all over, that have multiple batteries in there. And what do we do when we're done with that tool? A lot of times they get chucked in a toolbox and they bounce around in the back of the truck. What kind of impact is that making on those batteries? Lithium batteries have low relative weight. If you compare a lead acid battery to a lithium battery, lithium ion battery, there's no comparison. So in situations where we want to put some battery storage backup capacity for our buildings, just simply for weight savings in the construction of our buildings, lithium ions make a lot of sense. And they have limited memory. They don't have the same memory problems that other battery types have. And they live a relatively long life before they fail. And they're mostly cheap compared to other battery types. Really, the lithium ion batteries are kind of the whole package if you don't count safety into that overall comparison. So let's move on, or let's talk about what we use those for. We've mentioned a lot of these consumer electronics. You probably are touching something right now that has a lithium ion battery in it. You probably have multiple devices within arm's reach that have these batteries in there. And we talked about tools. E-bikes and scooters are a major challenge. Places like New York City have had tens of thousands of fires that have started because of e-bikes and scooters. This is a significant cause of fatal fires around the country, and in some of these jurisdictions, like New York, that's the number one cause of fatal fires. Are fires related to these types of lithium-ion batteries with e-bikes and scooters? Our EVs, I already gave some numbers on that, how many we're seeing, but the size of those is increasing. And the goal of some companies is to have our tractor trailers, our semis out there, all be EVs in the relatively near future. We have things like UPSs, uninterruptible power sources. You may have one of those under your desk that's designed to keep your computer functioning if the power happens to go down. Well, traditionally, these have been lead acid batteries inside of those UPSs, and they have their own problems. I've had those melt down over the years. But now we have something much more potent, and these are lithium ion batteries in those UPSs. And then we have this mass energy storage, the giant batteries that we've talked about, what we're seeing. Well, what's the big problem? You guys have been building up to this. What's the big problem as it pertains to lithium ion batteries? We kind of got the cart before the horse. Our technology changed and grew and improved far faster than our understanding of what the hazards were and the controls that we put in place. And unfortunately, now we have to deal with a lot of things that potentially have more safety issues than we might have expected before. So here we are. These batteries are not going away. They are going to be here. We're going to use those. So we've got to figure out a way to safely deal with those. So what are the hazards of lithium ion batteries? The primary hazard is thermal runaway. And what this means is it's a reaction, a chemical reaction that takes place. And once it gets going, it really can't be stopped. And it adds upon itself the temperature, it gets hotter and hotter. Um, and this is the major hazard of a lithium ion battery, but closely associated to that is fire. As these cells get hot, that electrolyte that's in the cells vaporizes and produces flammable gases, various different types, some hydrogen, some other gases, and all it needs is that ignition source, and then we can have fire and explosions from that. At the same time, if a fire happens in one of these cells, we can have toxic gases that are evolved from that. Electrical hazards. A firefighter going on the scene of an electric vehicle fire now faces a serious electrical hazard. These EVs are in systems that are about, whoops, I I think I hit the wrong button. They have about 3 to 4, well, currently they're 3 to 400 volts, and some new systems are designed at 800 volts. Well, that's a major hazard to our responders. These batteries can fail in a lot of different ways, from pressurizing, venting issues, ruptures of cells. They can react, like with the lithium metal batteries. If we get water where it's not supposed to be, they can react. Heat is a big challenge with those. If you've ever had your phone turn off when you're charging it, well, that's a good thing, right? That means our battery management system is working to prevent this heat buildup. Overcharging is a major cause of these hazards, along with short circuits and surges in voltage. All right, let's keep going here. So thermal runaway, like I said, this reaction is going to go to completion. And in some of the accidents we'll talk about, these things may go on for a long time when this reaction takes place. And what happens in these thermal runaways is sometimes our batteries are put together in cells, right? I have one individual cell, and that is attached to multiple, maybe dozens or hundreds of other individual cells in a module. And those modules may be stacked as well. And eventually we get that 77,000 pound battery system or energy storage system that we've got to deal with. Well, this thermal runaway can go from one cell to another. So I can have one individual cell that fails, and then it propagates itself to each of those other cells, and then we have a really big, really nasty fire and reaction taking place. Fire, like we said, thermal runaway really leads to release of flammable gases. And so as those gases come off, they're under high pressure. I think this one's interesting. Some dogs had got a battery, I think it was one of these systems like my backpacking battery pack, chewed on it on the dog bed, and it caught on fire and burned the house down. Fortunately, the dogs had a doggy door and they were able to get out, but all caught on tape. One consideration is that ignition of these flammable gases may not happen for a while. And sometimes, and we've seen this in accidents that have happened, that emergency responders, firefighters were trying to enter an area where a thermal runaway had taken place, and upon opening the door, whether it was whatever the ignition source, static electricity or something else, ignited those flammable gases and injured those responders going into that area. Um, and when we have a fire start, one of the major challenges with this, they're extremely hard to control, and they will spread and either consume buildings or other vehicles. And so we really need to consider the storage, how we store those, how close they are, where they're stored, especially in particular, these large battery systems. Where are we storing those? Because that could have a major impact on our buildings, on our overall operations. We could lose our entire fleet if the perfect storm came together. All right. Toxic gas evolution. When you burn things, uh, chemical reactions take place and it produces various different constituents. And in a lithium ion battery, those are some nasties. Hydrofluoric acid, HF, hydrogen cyanide, hydrochloric acid, hydrogen chloride, I guess, in a gas, carbon monoxide, sulfur dioxide, all of those things, even metal fumes, because the temperature of these fires will exceed 1,000 degrees Fahrenheit, and maybe even higher than that. And so our metals that are associated with the batteries can be turned into fumes that we may breathe. And so this is a really toxic soup of gases that can come out. All right. We talked about this already. Electrical hazards. You've got 300 to 400 volts, and there's no standardized way to isolate um, an EV electrical system. This is one of those cart before the horse things. We don't have a standardized way that our emergency responders will go in and either cut something or use the vehicle's isolation system to isolate that. And so we have the potential that if a mistake is made, our responders may cut into a 400-volt system and be electrocuted. And so it puts a real burden on our responders because they have to be looking at every EV that's out there. And how do you even tell what the model is or the manufacturer when the thing is involved in fire? And so what it's led to is many fire departments have a let it burn policy if it's in a situation where they have that option. The NFPA, National Fire Protection Association, has been working on this and trying to come up with standardization there and give our responders a little better option in knowing what to do. All right. That brings up this issue of stranded energy. And in our lockout tagout training, we talk about this, that you can have stored energy in a capacitor or a spring or something like that. It's stored energy that, if it's released, could cause injury to our people. And this is exactly what this is. And I know I'm talking a lot about EVs and fires involving EVs, but that's really one of the major concerns that we have, because they're big batteries and they're happening more and more often. So let's say we have a fire in an electric vehicle, and that fire damages the system to isolate the power. Well, I've got this battery that has a significant amount of power, and that's really where that thermal runaway is going to happen. Is that reaction, that power is going to be dissipated through the chemical reaction. How do I deal with that? And we may be faced with no safe way to discharge that energy. And after a fire has been extinguished, sometimes we have fires that will reignite. Sometimes, and we may have that shock hazard that's there. Hey, the fire's out, but the energy is still in the battery. And so we've seen cases where a vehicle catches on fire. The fire department puts the fire out. They load it onto a roll-off wrecker, and they haul it, or on a trailer of some sort, and they haul it to the wrecking yard. And a couple of days later, the vehicle's still sitting there, and it bursts into flames and melts down not only the rest of that vehicle, but the vehicle that it's on, the trailer or truck that it's on. And so consideration of, after we have damage to these batteries, well, what does that mean? Have we reached a zero potential on that battery so it's not going to pop back up? So we need to be smart about not storing damaged vehicles near buildings or vehicles. Some fire departments around the world, particularly in Scandinavian countries right now, are taking the step. They have trucks with a similar to a shipping container that has salt water in it. Salt water is something that will complete that reaction, something we don't want to get on batteries unless they're in this case, but they will basically take a crane and dunk this car into salt water to dissipate that energy. It's not a settled science in this case, and so I apologize if you came for all the answers here. They don't really exist on some of these things. However, on this stranded energy, there is a great NFPA video on this that will help us to understand it a little more. We don't have time to go through that today, and so the link is here on the screen. If you're watching this on YouTube, it's easy for you. We'll put a link right up here somewhere, and you can just click on that and watch that video. Okay, let's talk about some of the accidents that have happened from lithium-ion batteries. There was one that happened in, surprise, Arizona, in recent years. This was a data center, and this is the case where the firefighters were opening the door after they thought everything was okay, and those flammable gases were ignited, injuring multiple firefighters that were there at the door. In South Korea, battery manufacturer, they had one cell failed, and it ended up igniting tens of thousands of cells, and ended up killing over 100 people in that fire and explosion that happened from that. And in San Diego, there was an energy storage facility from a solar array, and when it failed, it burned for 16 days. They put 8 million gallons of water on this fire to extinguish it. We need to understand that if we don't have adequate water supplies, we may not be able to put these fires out. Then there was another one in Illinois, a battery recycling station there. They had 100 tons of used lithium batteries that caught on fire. They evacuated 1,000 homes, and it went on for a significant amount of time. And eventually, they brought in wet concrete and buried this fire in 28 tons of concrete to put it out. Those are the kind of things that we're facing with these large lithium-ion battery fires. Okay, so the question is, what do we do? Mike, maybe I'll take a breath just for a second. Do we have any questions that have popped up?
Nope, I don't have any questions right now.
Hey. All right, we'll keep going. So what do we do? Like I said, these batteries are not going away. We're going to have more and more of these, and they're going to be getting bigger and bigger and more complex. So we need to be prepared for these hazards. So a lot of you out there would be saying, well, what's the standard for this? What do we have to follow? What are the rules of the game? And the answer to that is they're still in development. They exist, but after that surprise Arizona fire, multiple standards were updated because of exactly what happened there, and the after action report that came out of it. So let's talk about just some basics. One is, if you're buying an appliance or buying a battery, it should be UL listed. That's kind of a standard practice for any electric equipment that we have. Is if I want a safe appliance or tool, it should have that little UL label on it that says that it's listed. There are other standards out there, the International Fire Code, and there are multiple different sections in there that relate to lithium ion batteries, talking about quantities, spacing, separation, um, protection from impacts, and also fire suppression. National Electric Code talks about backup batteries. We had a situation here at the Trust recently where we had a UPS system fail, not in the battery. It was another part of that system electronically failed, and it got hot enough. It was in our server room, and it got hot enough to trigger our waterless system. Years ago, when I started the trust, I said, "Hey, we have these servers. We need some protection for those," and so I recommended that, and we went through a capital process to put in this system to protect those servers in the event of a fire, without having our sprinklers have to go on and ruin the servers anyway. Well, after about 15 years, that system triggered, and it was due to a failure in this UPS system. It put the fire out before it got to the batteries. We were really fortunate in that situation, but I think this is something that all of us should look at as we are specifying our UPS systems or other backup systems, where we put those and what kind of protection that we have around those. So the National Electrical Code has that. NFPA, National Fire Protection Association, talks about installation. The standard is standard for installation of energy storage systems. So these are for the bigger systems, and it goes into a lot of details and calculations that you have to do. For most of you, this probably doesn't apply, but if you do have any of these larger systems, that's a good place to get started there. There are other things. FM Global is a large property insurer, and they're kind of the standard of the industry when it comes to developing protection. So they have good guidance. The Battery Manufacturers Association, Department of Transportation, deals with moving a battery from one place to another. EPA talks about if something catches on fire, if a battery catches on fire, it's hazardous waste, how we have to handle it, all of that. But one key component in all of this is your local fire department. Okay, fire department, we have this, or we're considering this type of battery system. What are, what are your capabilities? What should we prepare for, and what can you do? One of these standards, and it escapes me which one it's in right now, but it basically said you can't have any of these large battery. It's probably NFPA. You can't have any of these large battery systems above the height that the fire department can ladder to. And some jurisdictions, like New York, says you can't put these things on the roof of a building. And so we need to be aware of those. If we're bringing in a large system like this, we need to be aware of it. OSHA doesn't have a standard on lithium ion batteries. They sent out a information sheet, and I will distribute that. And it's really for small wearable lithium battery powered devices, is what it's called, preventing fire and explosion injury from small and wearable lithium battery powered devices. I'll send that out with the email reminding you about the YouTube replay of this. All right. Some of these standards are really based on the amount of power that is in a battery system. So the number of kilowatt hours of energy density that you have, that will decide whether a certain standard applies or not. All right, I've got a lot. I told Mike, I said, there's so much in here. I said, I'm trying to just kind of brush the surface, and I've got a lot of stuff here. All right, so let's talk about some basics of battery safety. Always, always, always use as directed. If there isn't an owner's manual, don't use it. Get the owner's manual and read what it says. This is how you should charge it. This is where it should be located. These are the conditions where you should not use it, or when you should take it out of service. do that. If you can't read the owner's manual because it's unintelligible, you probably ought to get a different device. Use only UL equipment. So if I'm buying a new tool or a new piece of equipment, make sure it is UL listed. Store these things away from combustibles. Everybody take a second and look under your desk and see if there's one of those UPS battery backups for your computer. If there is, are there any combustibles stored around it? If that thing ever fails and causes a fire, it will ignite combustibles. So we want to minimize the combustibles in the area around those UPS systems. Manage your charging. I had um, I brought in my show and tell. My kids gave me this flashlight for Father's Day, and it's a really cool flashlight. It's super, super bright. LEDs, lithium ion batteries. It's small, but it's just like a spotlight. Well, after I used it and the battery went dead, there's a little spot here you can plug a USB-C into, and it wouldn't recharge. I was really bummed. And I still haven't got anything out of the company to see if we can replace it. But when I tried to charge it, I plugged it in and it didn't charge. So I left it on there for a day. That may be outside of what is appropriate for that type of equipment. We already know this doesn't work. And so think about that. If a piece of equipment is damaged or we're concerned about it in one way or another, don't recharge it unless we know that it's okay. Manage your charging. Don't overcharge it. Don't charge it too fast. I I have been known to as I'm sitting in my car in the parking lot somewhere, I'll plug in my phone and set it up on the dash, and I've had it pop up a couple of times because the phone was sitting in the sunshine and it popped up and it said cannot charge now because of this. Have those battery management systems. So my phone has one, and guess what? It protected that battery in the phone from getting too hot. But think of our other systems. Battery management systems can monitor things like temperature and the rise in temperature. That's really what we're looking at in that thermal runaway. And also pressures and various other things can be monitored by that, how fast it's charging and all of those things. That battery management system is important. And then inspection, right? Inspect, inspect, inspect. We'll talk about that a little more in a minute. So battery abuse leads to thermal runaway. So what kind of abuse will do that? Mechanical. I throw that drill into the job box every day, 5 times, or once or twice a day. And over a period of time, that battery gets damaged, or I drop it on the job. That mechanical abuse can cause failure of those cells. Thermal, like I just talked, with hot temperatures, cold temperatures can also cause issues with these batteries, overcharging or over discharging. I pull that power out too fast. That can be a problem. How about salt water? Salt water is the enemy of these lithium ion cells. And so where do we put them? We put them at the bottom of our electric vehicles. And then we go out and we drive in the wintertime, splashing that salt water up onto there. Well, that would lead us to, hey, you know what? We probably need to wash our cars a little bit more if I have an EV because of that salt solution that's got up on the car. Our buildings, um, if we're going to have battery charging stations or we're going to have backup stations or anywhere where we have significant battery storage or use, it should be constructed of fire resistant materials. We should look at the spacing of our materials. If you've got a fleet of buses and we have a couple of electric buses, if it were me, I'd park them outside. Now I know that goes against some of the direction as far as temperature and all of those things, but those electric buses have more potential to take out our entire fleet than maybe a diesel or other type of bus that we have. Um, So where possible, have these things outdoors or away from other things. If I have a battery storage system, put it away from other buildings, put it away from things that we don't want to have destroyed if something goes wrong. And then look at our fire protection. If I do have some of these systems, get with the trust, get with your engineers, and look into the appropriate fire protection. What I saw in my research was the recommended fire or sprinkler density is about 3x what it would be for the same occupancy without those batteries in place. So it significantly increases the amount of protection that we put in those areas. If I'm dealing with these systems, like we said, the energy storage systems, because I've got solar arrays or wind power, which I know a number of our members of the trust are working with this right now, because there are tons of grants to help us put that in place. Well, that's where the NFPA standard on ventilation to vent those gases that can be flammable comes in. May even lead to deflagration panels. These are basically panels that blow out when we have a certain type of an explosion called a deflagration. It's a slow explosion that happens. Okay. And then facility inspections. Inspect all your batteries regularly. And when you think about how many you're going to deal with, this is a job. This is something that we're really going to have to pay attention to. Monitoring. One thing that works well, can work well, is monitoring for those explosive gases. Because like we said, sometimes when we have a failure of these batteries, we will release those flammable gases and toxics as well, but flammables for sure, ahead of when a fire may ignite. And so that can give us some warning that this is happening. We can also monitor their battery management systems and have those tied in. So that either goes to our alarm company or goes to us, so we can know ahead of time. All right, let's keep going here. And then protect your responders. If you work for an organization that has a fire department as part of your organization, and a rep from the fire department's not here, please ask them about this. Please forward on the email that I will send later on today with the link to this webinar, and make sure they're aware of these hazards and make sure that they have procedures in place. Sometimes we're going to need to modify those procedures because it's different dealing with an EV or a battery fire in a house or a business. Make sure that they are aware of those things. Modify your procedures if you need to, and then keep an eye on these standards and the changes in technology, because it is changing quickly. Like I said, some departments around the world are using these trucks full of salt water to dunk these electric vehicles to dissipate that stranded energy source that's there. Oh boy, we've talked about a lot of stuff. Here's a test of a thermal runaway and explosion in a home. Pretty crazy stuff. All right. In summary, know what you got. We all have exposure to lithium-ion batteries. We all, even in our homes, we need to be smart about these things. Don't charge up your scooter or your e-bike inside of your house. Do that in the garage or outdoors, away from your buildings, if that's possible. Treat your equipment the right way. Don't put your scooter out in the driveway in the St. George sun when it's 120 degrees there, because the chance of a thermal runaway goes really fast if we're out in that type of environment. Know your hazards, know your facilities, inspect. Where do I have those batteries? You should be talking with your fire department, and you should be talking with your IT department, because guess what? Information technology are the folks that are specifying our battery backup systems, and they should be aware of these challenges and use that knowledge when they specify what they're purchasing, where they put it, and what kind of controls they have around that. As you build new buildings, we've got to go into this with this in mind. If we're going to install a Tesla wall or other energy storage system in that building, we have to plan for that and make sure our building officials know what those new codes are as they come about, and protect our people, right? And particularly those responders, we want to make sure that we keep them safe as they're out there. Okay, that was a lot of stuff that we talked about. We'll open up now to questions and hopefully some answers on this. If you've got a question or a comment, please type it into the chat box, and we would love to hear it, and we'd love to keep this conversation going as well. So, Mike, what do we got?
Just a couple of points from Jeff, who gives some really good insight here regarding chargers and things like that. He
Mhm.
says the types of chargers, whether they're regular or rapid chargers, the faster you charge, the more heat you generate,
Absolutely.
which is a fantastic point. He also says if you have a fire and you know batteries are involved, relay this information onto the fire department because they're going to want to know that kind of information for sure.
Absolutely. Absolutely. Great comments there, Jeff. Thank you so much. Was that Chief Jeff?
That was Chief Jeff.
All
Yep,
right. Thanks, Chief. Appreciate it. Is that what we got?
that's it. That's all
All
we
right.
got.
I was worried about stump the dummy questions, so we're gonna wrap it up here because I did go a little longer than I anticipated on this. And
Real quick, Jason, before we go,
yeah,
one last question came across. Do you recommend charging a cell phone on a surface that is not combustible, like on not a carpet or something?
absolutely, absolutely. Whatever it is. I mean, I have a headlight, right? Little tiny. Here's a little tiny lithium ion cell. Well, where do you charge that? Don't put it around combustibles, right? I don't want to charge that there because it's small, but so's a match, right? And this has more energy than that match does, and it can ignite whatever those combustibles are on fire. And so I would look at that and say, all right, I've got all those pretty red Milwaukee tools. Um, where am I going to charge those? Well, don't charge them inside your house if you can avoid it. Take those out to the garage. If you've got a metal table or a cabinet that you put those in, that's definitely better to keep that away from anything that's combustible and obviously flammables, right? I don't want the gas can right there next to it. So, okay. Anything else?
Awesome. Nope, that's it. Well,
Uh,
what is the safe, appropriate way to dispose of old cell phones?
oh, great question, and one that I didn't include in here. Sometimes we got to get rid of these things, right? So they reach the end of their life. There are various different ways. Many manufacturers will take those back, and some retailers will facilitate that you can go in and say, "Hey, I'm getting a new phone. This old one doesn't work anymore. What do I do with it?" They may just take it back and put it back through the recycling process there. Um, don't throw these devices into regular trash. There are electronic waste and universal waste management that we can do with these batteries. Many of your communities will have a household hazardous waste collection area, and they may collect these electronic devices as well. So that would be the easy, responsible way to do it, and it really doesn't cost you anything. But and some manufacturers actually have a take back process where you can go online and request it. They will send you out a prepaid package, and you put the device in it, and you can send it back to them that way. So there are a lot of different options there. But great question. Great question.
Another comment from Chief Jeff, just some really good insight here. The biggest issues are the gases and the heat produced and the amount of water to cool down the cells and extinguish the fire. And I think you mentioned that, Jason, with the water that's required to extinguish a fire resulting from a battery.
Absolutely.
And Chief just echoes that point right here.
and we may be able to put out the fire, but that doesn't mean the reaction has stopped, right? That thermal runaway can keep going, and you know, that's that one example. It was 2 weeks before they got this fire under control. That's just amazing in my mind. And think about that. If we have to evacuate the neighborhood for 2 weeks, that's bad, right? Besides the damage that we have, that's going to be a public relations nightmare and potentially a really costly issue as well. So, yeah,
Yeah.
absolutely. Thank you so much, folks. Really appreciate your time and your comments on that and questions. Love to keep the conversation going. If you have that, Mike would be happy to answer any questions that you have. Uh, or myself, we'd be happy to do that. Give us a call or an email. Once again, we'll put this up on YouTube later this afternoon. And everybody, go out and have a safe day.
Thanks, everyone.